Preview video 8.6, volume of pyramids and cones. Sit up, lift up your chin, ready, and inhale. Deep breath, hold. And exhale. Ready, deep breath, inhale. Hold. And exhale. Taking a look here. Don't forget date, time, and location. So before we go on to pyramids and cones, let's recap prisms. Prisms, shade, base, equations, circle, plug, chug. Step number 1 in prisms is to identify your bases. And remember, CPR. Your bases, there's 2 of them. They are congruent, they're parallel to each other, and there's nothing but rectangles which connect them. So in this prism, those 2 right triangles would be the bases. Why? They are parallel to each other, completely parallel. They are congruent. They're the exact same shape, if you look carefully, the exact same shape. And there's nothing but rectangles that connect them. There's a rectangle there, and then a rectangle that connects down the front. That's how you know they're the bases. So we have a right triangle. Leg times leg over 2 is your right triangle. So we come here, one leg is 12. 16 is the other leg, over 2. So we get our base here is 96 km squared. There's your base. Volume, base times the height. And remember, height is not a vertical concept. It's the distance between the bases. So your height here is that 20. Circle, plug, chug, that base right there, 96. It's basically 96 times 2. And then we add a 0. Shade, base, equations, circle, plug, chug. Following the same process here, now we're doing pyramids and cones. And there's a specific concept. You must differentiate when we're dealing with pyramids and cones between something called a slant height and a true height. We'll be talking about that in about 45 seconds. Drawing pyramids and cones, you simply start with a vertex. Connect the corners to your base. And remember, edges that can't be seen, you must dot, which technically we have to dot that and not that. Follow along. All of these have a vertex, they have one base, and they have triangular faces. So prisms and cylinders have two bases, pyramids and cones have only one, and they join at a vertex. Now, to demonstrate the two different heights, I mentioned slant height versus true height. Let me introduce you to a great landmark that's in Edmonton, Alberta, Canada. I've got family there. This is called the Mintark Conservatory. Inside each of these pyramids is actually giant greenhouses. So you can see the snow on the outside, but inside they have heat and moisture. And there's actually, in that one pyramid you're looking at, a tropical of plants, a plant nursery, if you will. Now, you can see, so it's hollow on the inside. There's two different heights there. If you were to slide down the middle of the glass, like you're sliding down, kind of like a ski, that is called a slant height. So on the outside, down the middle, and we use a cursive L for that. If you were to be at the very inside top of the pyramid, and with a rope, go inside and straight down, I'm going to do dotted because technically you're inside. Over here you can see it better. Again, dotted because it's inside. At a right angle. That's called the true height. You need to know the difference between these two. So once again, to give you a quick illustration here, the slant height would be down the side of a pyramid or a cone. Okay? And the true height would be as if you were inside, like so, going straight up and down the middle. That's called the true height, also known as the altitude. Couple things. Pyramids and cones have two types of height. The outside height, also known as the slant height. The inside height, or the altitude. Right here, take a close look. Here is a slant height down the side. Here would the true height be. If you're dealing with a cone, there's a radius. Note that if you go up the slant height, down the altitude, and across on a radius, you're going to end up with a right triangle. So once again, you're going to be dealing with right triangle stuff. Volume is an inside measurement. Therefore, you use the inside true height. You don't use the slant height for volume. So you're going to use the inside true height, also known as the H. And put your hands like this real quick. Go like that. Go straight up and down. Say prism, pyramid, prism, pyramid. Imagine your hands making a prism and then going into a pyramid. You can see from a prism to a pyramid that you lose volume because you're coming to a vertex instead. Prism, pyramid. What do you lose volume by? Well, volume's 3 dimensions. Therefore, the fraction at which you lose volume from a prism to a pyramid is 1/3. 1/3. So the volume of a prism is base times height. Volume of this similarly shaped pyramid is base times height divided by 3. You lose by a factor of 1/3. Volume is 3 dimensions. So to reiterate, in a prism, you find the area of a base. Remember, capital B means area of times height. That's how you do volume of a prism. Here, again, area of that base times the true height on the inside, not the slant height. Be very careful you use the correct height, but it's over 3 because you lose volume by a factor of 3. That is your pyramid and cone equation. We're going to shade and trace the base here. Forgot to put the hatch marks. This is a square-based pyramid. We're going to find the area of said base. That's going to be 6 times 6. 36 cm squared is our base. We box that. We put our B here. Now, our slant height is 5. Take a close look here. We are missing our true height, which is right there. We need that. Question mark. Ready? I'd like you to trace from here to here. You're like, I need that too, don't I? Ready? Trace to 6. Trace the 6, trace this. See that little red dot? Trace it, please. Get your finger on your paper, please. You should feel that if this edge is 6, this edge right here, if that height goes to the middle, is going to be 3. So I'm going to pull out to solve for my slant height here. Unknown. This edge is 3. Have 2 sides, need 3rd side. Pathetic. You just found your height is 4. Now we have everything we need. Volume is base times height over 3. We have our base. Our base is already 36 centimeters squared. Our height is now times 4 over 3. Key to multiplying is not multiplying, it's factoring. You're going to get 48 cm cubed for our volume. You do this page completely on your own. Pause the video, restart when you're done. Okay, friends, you're switching to a red pen. Hopefully you're correcting your work and not just copying. That's a much better learning experience. We start by shading your base. And your base is a circle this time. So our base is pi r squared. Hopefully you traced the radius and figured out it was 9 and not 18. 81 pi. That is our base. Our altitude is our true height. It's 12. Volume of a cone, base times height over 3. 81 pi times your true height, which is 12, over 3. 3 goes into both 81 and 12. Didn't matter which way you went. We're just going to go this way. cancel 4. Our volume here is 324 pi cm cubed. You may leave it in pi form unless you have to do something else with it. Do your little summary, friends. Good job.